Hello students, welcome back to my YouTube channel. In this video, I am going to discuss about force acting on a charged particle moves in a combined electric and magnetic field. Okay, so in this video, I am going to discuss what are the important type of problems are going to be asked in NEET and JEE exams. Okay, so this is to be the part 2. So those who are not to be seen the part 1, please see the part 1 and come to part 2. Okay. Then the type 4. Ionized gas contain positive and negative ions. If it is subjected to magnetic field acting in plus Z direction and electric field acting in plus X direction, which direction ions deflect? Okay, what is the question? The question is saying that what in an ionized gas containing positive and negative ions. Okay, there will be a electric and magnetic field is to be acting perpendicular. In that region, this ionized gas is to be sent. What direction this ions will be moves? We'll see. So I am going to take it as the magnetic field is to be B is the magnitude and it is acting in Z direction. Okay, that is K, like that I am taking, and the electric field I am taking as E into IA, like that. Okay, so for a positive ion, okay, if a positive ion is sent into this region, okay, what will be happen? It will experience two forces, that is electrostatic force and magnetic force. What about electrostatic force? F is equal to Q into E. What is Q? If it is a positive charge, that is Q into EI. That means what is you can get the positive ions accelerated towards plus X axis. Okay, that means I can draw a diagram like this. This is X, this is Y. So what about this to be accelerated, the electrons are to be, this is to be Y and this is to be X. So the electric field is to be acting like this. So the magnetic field is to be acting like this. Okay. So what about the positive charge? Positive ions. Positive ions will be trying to move in this direction. It will be trying to accelerate due to this electrostatic force. One more force is there. What is that force? That is magnetic force. We will see. Now the charged particle is moves. Magnetic force F is equal to Q into V cross B. Okay, what is V cross B? Q into V value is how much? Here we got a V value. I am going to take it as V. In which direction? That is positive X axis. That is VI cross B value. That is BK. What about I cross K? We will take like this I J K. Anti-clockwise directions are positive. Here I cross K. I cross K is to be what direction? I cross K is in the clockwise direction. So it is to be negative minus, and it is in which direction? You get minus J, you will get minus QVB you will get. That means this magnetic force is acting in which direction? Electrostatic force is acting in this direction. Magnetic force is acting in which direction? Magnetic force is acting in this direction. The charged particle is deflected towards like this. Okay. Now the positive ions are moved towards. Sorry, this is to be moved toward the negative y-axis, so it will becomes like this. Okay. This is the magnetic force. Sorry, this is in the minus y-axis. That is like this. Okay, the charged particle is deflected like this. Okay, from this what you got? The positive ions are moved towards the minus y direction. Next we will see in which direction the negative ions will be moved. Okay. Okay, clear? The negative ions. If for the negative ions it will experience a what force? Electrostatic force, that is a physical, what you will get? That is QE, that is minus q into E value is at EI. That means the electrons are accelerated in which direction? That is, sorry, not an electron, that is negative ions. The negative ions are accelerated towards which axis? Minus x-axis. Negative ions accelerated towards minus x-axis. Okay? Then, now we will see what about the magnetic force acting on it. Magnetic force Fb is equal, what you will get? Q into V cross B. V is how much? The electron, the negative ions are started to accelerate in this direction, minus x-axis. So we will take it as minus Vi cross B. What about B value? That is Bk. Okay? So this. What about the cross product of this is to be negative ion, so we will take it as minus Q. What about the I cross K? I cross K, that is I cross K is in which direction? That is in the clockwise direction. Clockwise direction is J. Clockwise direction is minus J. Minus plus. So minus QVBJ we will get. So you see that here the electrostatic force this. This is to be electrostatic force. For this, we will see that the electrostatic force is to be acting in which direction? This direction, and magnetic force is acting in again in minus y direction. So this is deflected like this. So the negative ions also deflected towards in which direction? That is minus y axis. So both ions are deflected towards minus y axis. Okay? This is about type 4. Now we will see type 5. What about type 5? Q enters in a region how? Perpendicular E and B. V also perpendicular. It is not deflected. What about the B? Okay. So we will see this problem. Okay, this is to be given. So, electric field is to be perpendicular and B also perpendicular. So, if the net force is to be 0, then only the charge particle is not to be deflected. So, that means F is equal to what you will get? Fb. Then velocity is equal to what you will get? E by B. So, which of the combination will be satisfied this? We will see the first one. AK is what is there given? B cross E by E square. What you will get? What about B cross B? They are given E and B are perpendicular. So VB B sine 90 divided by E square. What you will get? You will get it as B divided by sine 90 is 1. B divided by E square. So what you will get? That is you will get B. You will get. Okay. This is not the answer. We will check the second one. I think. What is E cross B is equal to what you will get? E cross B divided by B square. E cross B is equal to E B sine. What about the sine? The angle between E and B is 90 degree. So like this and B square. Okay. So what you will get? E B divided by B square. So from this what you will get? That is E by B. This is the correct answer. Okay. This is the correct answer for the velocity. Okay, this is the correct answer. If you check it here become E cross E is equal to 0. E cross B, here also you will not get the B is equal to E by B, you will not get. So, the B is the correct answer for this. Okay, this is about type 5. Now we will see type 6. 2 microcoulomb charge moves in a region consists of electric field E is equal to 3J and magnetic field B is equal to 5I plus 3K with a velocity V is equal to 3I. What about the force? Okay. So here you see that if a charged particle, here a charged particle is moves in both electric and magnetic field. So it will experience a force F is equal to Q into E plus V cross B. Okay. So what about V cross B? I am going to find out. What about V cross B? V cross B we can find out I, J, K like this. What about the first vector I component? That is velocity I component is 3, now J component and K. Then B vector I component is 5 and now J component K component is to be 3. Okay. The cross product, first you take I, rows and column cancel. So what you will get? 3 0 0. So that is 0 minus j into rows and columns are cancelled. This rows and columns are cancelled. What you will get? 3 into 3, 9 minus 0. Okay, plus k into what you will get? This rows and columns are cancelled. 0 minus 0, 0. So what about v cross b? We will get the v cross b is equal to minus 9j. Okay. This I will substitute here. So what you will get? F is equal to what you will get? Q. Q is how much? 2 microcoulomb. 2 into 10 power minus 6 into what about the E value? E value is 3j minus v cross p value is 9j. Okay. So what is this? 9 minus 3 is to be 6. Here it is to be minus sign. So what you will get? F is equal what you will get? That is to be 2 into 10 power minus 6 into minus 6j you will get. So what you get? 12 into 10 power minus 6 minus j. Note this is the force. So force is acting in the minus y direction and the magnitude is 12 into 10 power minus 6 Newton. Okay. This is about the type 6. Now we will see type 7. Positive charge moving in xy plane initially along x-axis. Okay. Suddenly change in which direction? Change after P due to electric and or magnetic field. The path is not circular. They are given the option. Which option is possible? So what they told? Initially the charge particle is moving in which axis? It is to be moving in the x-axis. So I am taking the velocity v is equal to vi. Okay. Then they are asking if the electric and magnetic field together applied or only electric or magnetic field is to be applied. How the path is to be changed? Which option will be suitable for this? Okay. So I am taking the first one, first option. What about here? Electric field is 0, only the magnetic field. The charge particle is moving in the x-axis. The magnetic field is what? Bi plus ck. That means the magnetic field is making an angle with velocity. That means the charge particle is moves in which path? Helical path. Okay. So this is not a helical path. So it is not possible. So here also you see C option. Here also E is to be 0. So only magnetic field is there. So magnetic field is making here also making an angle with the velocity. So here also it is to be moved in a helical path. So the path is not a helical. So A and C is not possible. Next you will see what about D. D, it is A is there and E is there and B is there. So I am going to find out the V cross B here. Okay. I'm going to find out the V cross B. Two forces are to be acting. F is equal to Q into E plus V cross B. Okay. I'm going to find out the V cross B. What about the V cross B? That is I, J, K. Okay. What about the velocity? The first vector, the component. That is V is to be taken as Vi. That is this. Now J component, K component. What about the V? B. That is the second vector. There is no I component, that is to be 0. What about the J component? That is to be B. Okay, they are given it as B and the K component is to be Z. Okay, now I can expand this. Okay, I in the rows and columns are cancelled. What you will get? 0 minus 0, that is to be 0 minus J into what you will get? This rows and columns are cancelled. VC minus 0 plus K into rows and columns are cancelled. What you will get? VB you will get. So what you will get? Minus J VC plus K VB you will get. That means what? There is a Z component is to be there, but the charge particle is still in XY plane. So this is also not to be possible. This is not possible. This is not possible. This is not possible. Then surely which option is to be? That is to be B option. How we will check it is coming or not. So for a B option, what about the electrostatic force? That is equal to F is equal to Q into, I am taken as Q into E. E is in which direction? They are given as Q into A I. This direction electric field is to be acting. And what about the magnetic force? Magnetic force equal to Q into V cross B. Okay. So V cross B we are going to find out. V cross B. What about the V cross B here? I, J, K. Okay. I value is how much? For a first vector, that is V is equal to V. There is no J and K component. Next B vector. For B vector, what they are given? That is to be, its I component is A and no J component, K component is to be Z. Okay. We'll expand this. We'll expand like this. So what you'll get? That is V cross B is equal to I into rows and columns are cancelled. What is you'll get? 0 minus 0. That is to be 0 minus J into rows and columns are cancelled. VC into 0. VC minus 0. So minus plus K into rows and columns are cancelled. This 0. Okay. So what you'll get? Minus JVC you will get. This is about a V cross B. Then what about the magnetic electrostatic forces in which direction? That is to be in I direction. So we can see that. So the magnetic force is acting in which direction? The magnetic force FB is equal to what you'll get? Q into, that is VC minus J. That means the magnetic force is to be acting in the Y axis and the electrostatic force is acting in the I direction. So listen here. The charge particle is trying to accelerate by this electric field in the I axis, but due to magnetic field it is deflected like this. Okay, so this is the correct answer. If electric field is not there, what happened? The charge particle is moves in a circular path. They are given it is not a circular path, so compulsory B is the correct answer. Okay.